The question is to find the equilibrium level of income. The question goes like this: what is the equilibrium level of income given this income identity, that is y is equal to c plus I plus g. C is the consumption expenditure, I is the investment expenditure, g is the government expenditure. Consumption function is being given as 31 plus 0.8y. Investment is autonomous, which is 9, and government expenditure is also autonomous, which is 10. The options are being given. We need to find out the correct option. Okay, so using this identity, that is total income is equal to consumption expenditure plus investment expenditure plus government expenditure. Okay, now our consumption is being given us is 31 plus 0.8. Let us write it in place of c. 31 plus 0.8y plus investment is being given as 9 and government spending is 10. This is our y, which gives us, transposing this to LHS, it will get subtracted. 0.8y is equal to, so we have 31, 9 and 10. So 31 plus 9 is 40, 40 plus 10 is 50. Now we need to do one thing here. Let us take y common here. So if I take, or let us subtract 0.8 y from y, so we will be left with 0.2 y is equal to 50, or 0.2 y can be written as 2 upon 10 y is equal to 50, which gives us y is equal to 50. If I transpose it to the RHS, it will get multiplied and reciprocated. So 10 upon 2, that gives us y is equal to, so we have 2 ones are 2, 25s are, so 25 into 10 is 250. That means our equilibrium level of income will be equal to 250. The question is to find out the optimum unit of labor. The question goes like this: the production function of a firm is x is equal to 5 times k to the power 1 upon 2 times L to the power 1 upon 2, where x is the output, k is the units of capital, L is the units of labor. Given capital is equal to 16 units, price of output is $6 and wage rate is $5 per unit. Find the optimum unit of labor. The options are 140, 142, 144 or 148. Okay, so what we are being given, let's rewrite it. So output is a function of 5 times k to the power 1 upon 2 L to the power 1 upon 2. K is fixed, which is being given as a 16, and price of x is equal to 6. Okay, we need to find out the optimum units of labor. For that, what will we do? First, we plug the value of k in this equation in the production function, that is x will be equal to 5. So we have 16 raised power 1 upon 2 times L to the power 1 upon 2. That gives us x will be equal to 5. Now 16 raised power 1 upon 2 is 4 times we have L to the power 1 upon 2. L to the power 1 upon 2. So our x is equal to 20 L to the power 1 upon 2. Okay. Next thing is, what is the condition for employing the labor, the optimum units of labor? It is simple. To maximize profit, a manager will hire labor until the value marginal product of labor is equal to wage rate. That means, let me write it here. To maximize profit, firm will hire labor till or until value marginal product of labor is equal to wage rate, and wage rate is being given as 5 here. Now this value marginal product is simply equal to price of the product, this, times marginal product of labor, and it should be equal to wage rate. So first we need to find out the marginal product of labor. Marginal product of labor will be simply the derivative of production function with respect to labor. Okay, taking derivative of this function with respect to labor, L here. So by power function rule, the exponent will become the coefficient. We have 20, L to the power, exponent will be subtracted by 1. Okay, so this becomes 10, L to the power minus 1 upon 2. So this is our MPL. So let's write it here. Price of X is being given us as 6, so I can write here 6 times 10 L to the power minus 1 upon 2 should be equal to the wage rate that is being given us as 5. So which implies 60 upon, if I transpose it here, it will become L to the power 1 upon 2. Exponent sign will get changed when we transpose numerator to denominator, should be equal to 5, which implies 5 cross multiplying. Okay, so we have 5 L to the power 1 upon 2 should be equal to 60. Let's rewrite it here. So L to the power 1 upon 2 will be equal to 60 upon 5. That gives us L raised power 1 upon 2 is equal to 12, or L will be equal to, if I transpose this exponent, it will remain exponent but reciprocated. Okay, so if it is 1 upon 2, it will become 2 upon 1 here. So L will be equal to 12 into 12 is 144. That means optimum units of labor required will be 144. Okay, this option. The question is to find out the optimum expenditure. The question goes like this: the monthly income of a consumer is $4,000 to be spent on either good X or Y, having the price of good X is $2, price of good Y is $4. The marginal utility of good X is 3 upon X, and marginal utility of good Y is 9 upon Y. We have to find out the optimum expenditure on good X. Okay, so what we are being given? We are being given the total income or monthly income of the consumer is $4,000. Price of good X is equal to 2. Price of good Y is equal to 4. Okay, and also we are being given marginal utility of X is being given as 3 upon X, and marginal utility of good Y is being given as 9 upon Y. Okay, we need to find out the optimum expenditure on X. So how do we find? First we need to find out the first order condition for optimization. Okay, first order condition for optimization requires that marginal rate of substitution between good X and Y should be equal to the ratio of the prices, that is price of X upon price of Y. MRS is simply marginal utility of good X upon marginal utility of good Y. It should be equal to price of X upon price of good Y. Okay, also we need to construct the budget constraint. What will be the budget constraint? Simply that will be X into price of X plus Y into price of good Y should be equal to the total income, and price of X is being given 2, so we can write 2X plus price of Y is 4, we can write 4Y should be equal to $4,000. Okay, so I forgot to write it first, in the first place. Now marginal utility of X is being given as 3 upon X divided by marginal utility of Y is being given as 9 upon Y should be equal to price of X upon price of Y. Price of X is 2, price of Y is 4, which implies I can write it in this fashion: 3 upon X. If I transpose it to the numerator, it will get multiplied and reciprocated. Y upon 9 should be equal to 1 upon 2 upon 4 is 1 upon 2. So 3 ones are 3 threes are. So I will get here Y upon 3X is equal to 1 upon 2, which gives us y will be equal to, so 2y is equal to 3x, which gives us y will be equal to 3x upon 2. Now we need to plug the value of y into the budget constraint to get the value of x, optimum value of x. Okay, so you simply plug the y is equal to this into the budget constraint. So we have 2x plus 4 in place of y we have, okay, so in place of y we have 3 upon 2. I hope I am making the calculation right. Should be equal to 4000. So here 2 1s are 2 2s are 4. So this is 2 3s are 6. 7 is 8x. So 8x should be equal to 4000. Okay, which gives us, we have 3 upon 2. Okay, I hope I am we have 2y is equal to 3x, so 2y is equal to 3x, y is equal to 3 upon 2, so that's clear here. So 8x upon 8x is equal to 4000, which gives us x will be equal to 4000 divided by 8. So we have x will be equal to 8 1s are 8 5s are, so we got x is equal to 500. That optimum units of good x will be 500. Now expenditure on good x will be simply equal to, so let me write it here, expenditure on x will be equal to simply price of x times optimum units of x. Okay, let us write it as x star. So x star, price of x is being given us as 2 times optimum units of x is 500, so which gives us as 1000 as the optimum expenditure on good x. So the correct option should be D part. The question is, when change in government expenditure, that is del G, is equal to 2, change in tax, that is del T, is equal to 2, what will be the impact of fiscal policy on consumption? The options are 0, 2, 3 or 1. Okay, now first we need to find out the fiscal policy multiplier. What is the formula for fiscal policy multiplier? This is being, let me write it here, fiscal policy multiplier. Okay, it is being given like this. I have explained this, so let me write it here first. Del C is equal to MPCD upon 1 minus MPCD into del G minus del T. If you are if you are confused where does this equation came from, this formula came from, I have explained this very formula, I have derived it. I will put the link into the description box and also into the info button of this video. Okay, so remember this very thing, you can solve this the given question. Now what we are being given, we are being given change in government expenditure is 2, change in tax. Okay, so let me write it here, tax is equal to 2. We have to find out the change in consumption. Okay, now let us use this formula. So change in consumption is equal to MPCD, their marginal propensity to consume of disposable income, minus 1 minus MPCD. Okay, so what is del G? Del G is 2 minus what is del T, that is 2. Okay, so this becomes del C is equal to this very thing multiplied by, so 2 minus 2 comes out to be 0, so this very thing, so let me write it here, MPCD upon 1 minus MPCD into 2, multiplying this very thing with 0 will become 0. That means change in consumption will be equal to 0. Okay, so actually we have this tells us that change in consumption is directly proportional to budget deficit. But since we have equal amount of change in del G and del T, that means 2 minus 2, there is no change in the budget deficit. Okay, our consumption, change in the consumption will be equal to 0. Okay, I hope. The question is, the average cost function is given as average cost is equal to 1 by 3x square minus 10x plus 9. The level of output at which average cost is equal to marginal cost is, the options are 18, 12, 15 and 21. So basically we are given the average cost, so we write here average cost is given as 1 by 3 x square minus 10x plus 9. Okay, so we have to find the marginal cost. We are given the average cost, so to find the marginal cost we have to find the total cost first. Okay, and we know that total cost is simply average cost times quantity, that is x here. Okay, so our average cost is this, so I will write here 1 by 3 x square minus 10x plus 9, and we multiply it by x to get the total cost, which will come out to be, that is 1 by 3 x cube, multiplying this x to all the terms in the brackets, minus 10x square plus 9x. This is our total cost, so I will write this is our total cost. Now we will find the marginal cost. Marginal cost is simply the derivative of total cost, okay, with respect to x, which is here quantity. So we differentiate this total cost function with respect to x. So here we are 1 by 3, the derivative of x cube is simply 3x square, that is 3x square, because this 3 becomes coefficient and the exponent is subtracted by 1, so 3 minus 1 is 2. This 3 becomes the coefficient and it is multiplied with the other coefficient, minus we have 10, the derivative of x square is 2x, this 2 will become the coefficient, that is 2x, and power is subtracted by 1, that is 2 minus 1 is 1, so we write x to the power 1 as x. Plus 9, the derivative of x is simply 1 here. Okay, how it is 1? Since it is x to the power 1, this 1 becomes the coefficient, so 1 into x, and this power is subtracted by 1, this becomes 1 x to the power 1 minus 1 is 0, and we know x to the power 0 is equal to 1. Okay, anything raised to the power 0 is equal to 1. That is how we got here the derivative of x is 1. Okay, now the question tells us the level of output at which average cost is equal to the marginal cost. So we have to equate average cost with marginal cost to find the level of output. Okay, our average cost is given, so I will write here 1 by 3 x square minus 10x plus 9. This is our average cost, and we have to equate it with this the marginal cost, which is, so here this 3 and 3 will get cancelled. We get here x square minus 10 twos are 20x plus 9. Okay, now solving this will come out to be 1 by 3 x square, transposing here, this is minus x square minus 10x, rather we will not transpose this, and we have 9 plus 9, and this when transposing will become negative 9 is equal to minus 20x, and we will transpose this minus 10x, this will become plus 10x. Okay, so here we have this is x square minus 3x square, this will become so I will write here x square minus 3x square divided by 3 ones are 3 plus 9 minus 9 will get cancelled here, minus 20x plus 10x is equal to minus 10x. or we can write x square minus 3x square is minus 2x square divided by 3 is equal to minus 10x. This minus and minus gets cancelled, and we have x here and also x here. This also gets cancelled, so we will get 2 by 3 x is equal to 10, or 2 by 3, rather let me rub this, or x is equal to 10 into transposing this 2 by 3 on RHS. This will get reciprocated, so here it is 3 by 2. Now 2 ones are 2 5s are 10, 5 3s are 15, so x is equal to 5 3s are 15. That is the level of output where average cost is equal to marginal cost is equal to 15. And graphically it simply means, if this is our average cost and this is our marginal cost, the intersection of these two occurs where our output level is, if it is quantity, so the level of output where average cost and marginal costs are equal is 15. I hope in this video we will solve a numerical problem on the relationship between price elasticity, income elasticity, and elasticity of substitution. This question was asked in JNU PhD entrance exam of 2022. The question is, find the price elasticity, that is EP, of a commodity X when total budget is spent on two commodities X and Y, and income elasticity is given as 2, and elasticity of substitution is being given as 3, and 1/10 share of income is spent on good X. We are being given the options 2.95, 1.5, or 1. Okay, so we need to find out the price elasticity here. Okay, so what we are being given here, let us see. We are being given, we have two commodities X and Y. Okay, also we are being given the income elasticity equal to 2. Elasticity of substitution is being given us as 3, and income spent, let me write it in this fashion, income spent on good X is 1/10. That means share of income spent on good X is 1/10 of total income. Okay, now what we need to find here, we need to find here the elasticity, price elasticity. What will be the price elasticity? Okay, now here price elasticity of demand is given by the Slutsky equation in this case, and that is being given us as, that is elasticity, that is price elasticity is equal to, that is equal to share of income spent on good X times the income elasticity plus 1 minus the share of income spent on good X times elasticity of substitution. This is the relationship between the price elasticity, income elasticity, and elasticity of substitution. Basically, this equation tells us that price elasticity, is being influenced by the income elasticity partly, and by the elasticity of substitution partly here. Okay, this this first term shows us the influence of income elasticity on price elasticity of demand, and the second term shows us the influence of substitution effect on price elasticity of demand, and the magnitude of this, in turn depends upon the elasticity of substitution. And let us give the variables their values. So price elasticity will be equal to, now share of income spent on good X is 1/10. Let me write it here, 1/10. Income elasticity is being given as 2. Okay, I have written it small letters here, capital, my mistake. So here we have 2 plus 1 minus income, share of income spent on good X is 1/10 times the elasticity of substitution is being given as 3. Okay, we solve this becomes 2/10 plus this is 10 now upon 10, 9/10 into 3. So this results in 2 upon, let me write it here, price elasticity will be equal to 2 upon 10 plus 9 threes are 27, 27 upon 10. So price elasticity will be equal to, denominators are same, we can add up the exponent. So it is 29 upon 10, which gives us elasticity equal to 29 upon 10 is 2.9. That means price elasticity will be equal to 2.9. That is, the first option should be correct. The geometric mean of numbers 2, 4, 0, 16, 32 will be equal to, the options are 3.2, 4.0, 2.0 and 0. So geometric mean is simply, as we know, geometric mean is equal to nth root of the product of the numbers. That is, if we are given the numbers, let us say if we are given three numbers, 1, 2 and 3, and if we have to find the geometric mean of these numbers, what we do, we just multiply 1, 2 and 3 and take the cube root. Okay, similarly, if we are given only two numbers, let us say we have to find the geometric mean of 2 and 3. In this case, geometric mean would be simply 2 into 3 and taking first and second root, that is 1 by 2. Okay, similarly, if we have n numbers, then we take the nth root. In this case, we have the numbers, we are given the numbers 2, 4, 0, 16 and 32. That means geometric mean is simply, we just multiply these numbers, that is 2 into 4 into 0 into 16 into 32 and take the 1, 2, 3, 4, 5, fifth root, that is 1 by 5 raised power. So it's quite simple here. Since 0 is here, any number multiplied by 0 would be equal to 0. So this is 0 to the power 1 by 5, which is equal to 0. That means the geometric mean in this case would be 0. So geometric mean, whenever we have a set of observations and one number in the observation is 0, then the geometric mean of the whole observation will be 0. Okay. Next question is, what will be Keynesian multiplier when consumption function is being given as 10 plus 0.8 yd, where c is consumption, y is the income, and import function is being given as that m is equal to minus 6 plus 0.3 y. The options are 2, 3, 4, 5. Okay, so what is the Keynesian multiplier? Keynesian, let me write it here. Keynesian multiplier is equal to 1 upon marginal propensity to save plus marginal propensity to import. Okay, so we have consumption function c is equal to 10 plus 0.8 y. What is our marginal propensity to save? Here this is our MPC. Okay, this is our MPC, is that is marginal propensity to consume is 0.8, and we know that marginal propensity to consume plus marginal propensity to save is equal to 1. MPC is 0.8, so we can add 0.8 plus MPS is equal to 1, or MPS is equal to 1 minus 0.8. That means our marginal propensity to save comes out to be 0.2. So we can write here 1 upon, in place of MPS we got the value 0.2. And what is our marginal propensity to import? Okay, in this equation, import is a positive function of income, and this denotes our marginal propensity to import. That means this is our MPI. Okay, so in place of MPI I can write 0.3. This comes out to be 1 upon 0.5, and when we write it like this, 5 upon 10 reciprocating, this becomes 10 upon 5, so this comes out to be 2. Okay, so the correct option should be 2. Our Keynesian multiplier will be equal to 2 when we have the consumption function and import function give deficit. The question is like this: one marginal rate of tax is 2 upon 3, change in government expenditure, that is del G is 1, marginal propensity to consume is 1 upon 6, find budget deficit. The options are 1 upon 5, 1 upon 6, 1 upon 4, or 1 upon 7. Okay, so actually what we are being given here, marginal rate of tax is equal to 2 upon 3. Okay, our change in government expenditure is equal to 1, marginal propensity to consume is being given us 1 upon 6. We have to find out the budget deficit. Okay, so how do we solve this question? What is budget deficit? Budget deficit is equal to change in government expenditure minus change in taxes. Simply, this is our total government expenditure, this is our total tax revenue. Okay, so budget deficit is equal to del G minus del T. Okay, if government tax is greater, if government revenue is greater than expenditure, at that time we have budget, what you call surplus. If government expenditure is greater than the total tax revenue, then we would have budget deficit. Okay, this is the formula for budget deficit. Now we can also write it like this: we have del G minus, now change in tax is equal to tax rate times change in income. Okay, I'm talking about this del T. In place of del T we can write T into del Y. Okay, change in tax revenue will be equal to the tax rate times change in income. Simple. Now what we also need to find out here, we need to find out this del G. Okay, we need to find out the change in income with respect to change in government expenditure. That means we need to find del Y upon del G. That means we need to find the government expenditure multiplier, and it is simply 1 upon 1 minus MPC. Okay, I have explained it a number of videos how do we calculate this, so I will not explain here again. Okay, so what is our 1 minus MPC? So this is our 1 minus 1 upon 6. This is our MPC. If we solve it here, so this comes out to be 5 upon 6. Okay, so this is 1 minus MPC. So here I can write 1 upon 5 upon 6. So this is del Y upon del G came out to be, transposing this it will get reciprocated, it will become 6 upon 5. That means del Y is equal to 6 upon 5 del G. Okay, rather this is our relationship between the change in income and change in government expenditure. Okay, now what we are being given here, what is del G is 1, so in place of this I can write 1. That means del Y is equal to 6 upon 5 into 1. So this is del Y is equal to 6 upon 5. So we got the value of del Y. Okay, so we need to find the del Y. Okay, del G is being given us. Then our budget deficit is simply, budget deficit is equal to this del G. Actually we have to calculate the tax rate, rather the tax rate is also being given us here, marginal rate of tax is also being given here. So our del G came out to be, which is being given as 1 minus this T is our marginal rate of tax, that is 2 upon 3, 2 upon 3 into what is our del Y. Del Y we calculated, it came out to be 6 upon 5. Okay, so this is 1 minus 3 ones are 3 twos are 6, 2 twos are 4 upon 5, 4 upon 5, which comes out to be 5 5 minus 4, 1 upon 5. That means our budget deficit will be equal to 1 upon 5. I guess this option should be correct. Okay, so how do we calculate it? First we know that budget deficit is equal to this very thing. Okay, since we were to use this very formula, and if we rearrange this, we can write del G minus, in place of del T, this is marginal rate of times our change in income. Now first, after that, we need to use this very formula, that is change in total income. Rather, we use the government expenditure multiplier to get this del y. Okay, to get the value of this del y. And when we solve it, del y came out to be 6 upon 5 into del g. The value of del g, we know it is equal to 1, so that means our del y was 6 upon 5. Okay, after that, we used this budget deficit formula, this very formula here, and we got the value of our budget deficit. Thank you. The question is like this: if MPCD, that means marginal propensity to consume of disposable income, is equal to 1 upon 5, marginal propensity to consume of total income is equal to 1 upon 4, find tax multiplier. The options are 4 upon 15, 2 upon 15, 1 upon 11, or 1 upon 17. Okay, so what we are being given here, we are being given here marginal propensity to consume of disposable income is equal to 1 upon 5. Okay, marginal propensity to consume of total income is equal to 1 upon 4. Okay, now there is a beautiful relationship between these two MPCs, that is marginal propensity to consume is equal to MPCD, okay, minus T, that's tax rate, MPCD. Okay, this is the relationship between marginal propensity to consume of total income and marginal propensity to consume of disposable income. That means total MPC is equal to MPCD minus T times MPCD. Okay, so what is our MPC? MPC is 1 upon 4 is equal to this very thing. MPCD is 1 upon 5 minus tax rate that we need to find out to calculate the tax multiplier. So we have T into 1 upon 5. Okay, we can write it like this: 1 upon 4, taking 1 upon 5 common, this is 1 minus T, or we can write 1 minus T is equal to 1 upon 4. Transposing this will get reciprocated, 5 upon 1, so 1 minus T came out to be 5 upon 4. Okay, or if you transpose this here, so this becomes 1 minus 5 upon 4 is equal to T, so this comes out to be our T is equal to 4 minus 5, this is minus 1 upon 4. That is our tax rate. Okay, marginal tax rate. Now what is the formula for tax multiplier? Now tax multiplier is being given here like this: tax multiplier formula is, that means change in income upon change in tax is equal to minus marginal propensity to consume, that means MPC, okay, D upon 1 minus, let us denote this MPCD by any term, so let us write MPCD as C dash. Okay, so I can write it like this: minus C dash is equal to 1 minus C dash plus C dash T. Okay, this is the formula for tax multiplier. If you wonder how does this came out to, I have explained it in earlier videos how to calculate the multipliers. Okay, so this is the tax multiplier. It simply changes, tells us how much our income will change if we change the tax. Okay, so using this very formula, that means del y upon del t is equal to, what is this? Marginal propensity to consume of disposable income, that is being given us as minus 1. Let me write it here: minus 1 upon 5. After that, we have 1 minus c, again this is being given as 1 upon 5 plus 1 upon 5 into tax rate is minus 1 upon 4. Okay, when we solve this, we have 1 upon 5 in the numerator. Here this is 5 ones are 4 upon 5. 4 upon 5 minus, we have then 1 upon 5 fours are 20. Okay, solving again, we have, this is negative. Okay, minus 1 upon 5 upon, so making denominator same, so multiplying this by 4, so this becomes 4 4 are 16. So we have 16 minus 1 comes out to be 15. Okay, 15 upon 20. Okay, so this is minus 1 upon 5 into 20 upon 15. Okay, so we have 5 ones are 5 fours are, this comes out to be minus 4 upon 15. Okay, so the correct option should be minus 4 upon 50, but in the options we have only positive values, so I guess this should be the correct one. Okay, we got the negative value. Either the options are not correct. Since the options are not correct, but the possible appropriate answer to this question should be 4 upon 50 if we assume that option is correct. Otherwise option is not correct, where we should have like this minus 4 upon 15 as option. Okay, so let's go for this, otherwise the option is not being given correct. Thank you. If elasticity is greater than 1, total revenue has day slope positive, negative, 0 or none of these. Okay, so how to find this? We have the linear demand curve, and I have explained it in clear terms in the earlier video that elasticity along a demand curve changes. Okay, it is not constant. Okay, so upper half segment of this demand curve has elasticity greater than 1, lower half segment has elasticity less than 1, and at midpoint we have elasticity equal to 1. By elasticity here we mean the absolute elasticity. Okay, now let us see what happens to the total revenue in this upper half segment. The question tells us when elasticity is greater than 1. Okay, so let us say when price is 5, quantity demanded is 1, that means total revenue is 5 into 1. Total revenue is being given by total revenue is simply price into quantity. So at this point we have 5 into 1, so our revenue is 5. Okay, let me write it here. So we have this point is 5. Okay, now when price falls to 4, quantity demanded increases to 2. What is the total revenue at this point? So we have again price into quantity, 4 2s are 8, so we have another point which will lie here. Okay, now what is the elasticity when price falls? When price falls to 3, quantity demanded increases to 3. What is the total revenue here? 3 3s are 9, so we will have this point here. Okay, and when price falls to 2, quantity demanded increases to 4. Total revenue is price into quantity, that means 2 into 4 is 8. Again we will have this point here. Okay, then lastly when price falls to 1, quantity demanded increases to 5. So let me write it here. So 1 into 5 is 5. Let us say this is here. Okay, if we join these 2 pointers, the point that I want to make here, this denotes our total revenue curve. Okay, it looks like this. When elasticity is equal to 1, our total revenue is maximum. Okay, maximum. When elasticity is less than 1, our total revenue decreases, and by total revenue we mean decrease. That means the total revenue has negative slope. Okay, negative slope. You can see here the slope of this curve will be negative. And when elasticity is greater than 1, in this region total revenue has positive slope. Total revenue has positive slope. Okay, so the question was, if elasticity is greater than 1, total revenue has what slope? We can see when we are at this portion, the total revenue will increase. When we are at this portion, total revenue will decrease. And when we have unit elastic demand at this time, we have total revenue maximum. Okay, if you are wondering how does this elasticity change, I have explained it in earlier video in clear terms. How does the elasticity of a linear demand curve changes? Okay, changes along the different points on this demand curve. Okay, so the point to here make is when we are what we call upper half segment of demand curve, elasticity is greater than 1. By elasticity I mean absolute value of the elasticity. Otherwise we will get here elasticity will be minus 5, and when we take the absolute value we will write it like this: absolute we change this sign, okay, so we get 5. Okay, given two regression lines y on x and x on y as follows, that is 3x plus 2y is equal to 26.0, 6x plus y is equal to 31.0. Sorry, then there or that is coefficient of correlation will be, the options are 0.4, 0.5, 0.6 and 0.7. Okay, first of all we will find the relationship between the correlation coefficient and regression lines is given by rather and the regression coefficient is given by, that is r is equal to product of the regression coefficient, that is beta yx times by xy. So I will write here xy, that is byx times bxy. So first we calculate byx. Okay, since the first equation is y on x is given this, so we can solve this. 3x plus 2y is equal to 26.0. We solve this for y, so this is 2y would be equal to minus 3x plus 26.0, or y is equal to minus 3 by 2x plus 26.0 divided by 2. That means our b yx, that is regression coefficient is here, and regression coefficient is simply the slope of this line. So the slope of this line is here minus 3 by 2. Similarly we will take this very line and solve for x because it is given x on y. So we can write this equation, that is 6x plus y is equal to 31.0, and solve for x, that is 6x would be equal to minus y plus 31.0, or x is equal to minus 1 by 6 times y plus 31.0 divided by 6 here. That implies our beta xy would be simply the slope of this very line. Okay, the slope is simply this very equation, that is the coefficient of y would be the slope, which comes out to be minus 1 by 6. Now we can use the formula, that is beta yx, sorry I'm saying beta, it is b, actually byx, which is minus 3.2 multiplied by bxy, that is minus 1 by 6. Here minus minus will become plus because they are in the multiplication. So 3 ones are 3 divided by 2 6 are 12. So we will get this comes out to be 1 by 4. Now 1 by 4, as you know, it is equal to 0.25. Now the 0.25 is simply 0.5 square root gets cancelled, we get 0.5. That means our r is equal to 0.5. So the correct option would be this option, that is option B. The question is like this: when marginal cost is given as 10 plus 0.4x, marginal revenue is 30 minus 0.6x, damage borne by the society is 10. In the case of externality, find the deadweight loss. So we have to find the deadweight loss. The options are 50, 60, 40 or 80. Okay, so I have explained this very stuff in the earlier video. Now let us see, let's recapitulate what how do we came out with this graph. Okay, first we were being given the marginal cost. Here this marginal cost will denote our marginal private cost, which is being given as 10 plus 0.4x. Okay, our marginal revenue will be our marginal benefit curve. Okay, so let me write this is also our marginal benefit curve. Okay, and it is being given as 30 minus 0.6x, where x is the output produced. Okay, damage borne by the society means that our marginal external cost is equal to 10. Okay, now how do we arrive at this point? Just we equated our marginal private cost, this marginal private cost, with our marginal benefit curve. That means demand and supply when intersect, we got 20 as our output and price is 18. Okay, so when we solve this, we got the value of x is 10, then price will be equal to our marginal benefit curve, okay, intersection point. So that is p is equal to 30 minus 0.6 into the value of x, which we calculated, that was 20, and we got the equilibrium price is 18. Okay, after that we calculated this very stuff. Okay, uh, rather we calculated marginal social cost. Now what will happen, since we are producing here, when there is a cost borne by the society which is equal to 10, then our marginal social cost will be equal to the marginal private cost, okay, plus the marginal external cost. Okay, so the aggregate of this curve and this 10 will give us this very supply curve, which is equal to with intercept obviously 20. Okay, this will change, since originally the intercept was 10. When we have marginal private cost, since there is cost borne by society equal to 10, then the intercept will increase by 10 units, so this will become 20 here. Okay, after that we calculated the producer surplus in the earlier video, and also we found out the equilibrium. Okay, now in this video we need to find the deadweight loss. Now what will be the deadweight loss, since originally we were producing at that very this very point. Okay, this was the point where our marginal private cost and marginal benefit curves intersect. But at the socially optimal level, when we take into consideration the cost borne by the society, that is equal to 10. Okay, so this vertical intercept here, this vertical distance is 10. Okay, now what will be the deadweight loss to the society? Deadweight loss will be simply, since we achieved this very point, ordinarily we were here. Okay, then our deadweight loss will be the area of this very triangle. Okay, so this very triangle will give us the deadweight loss. Okay, because we are not producing at what we call at this very what we call that the market efficiency point. Okay, so this very triangle will give us the deadweight loss. Okay, and what will be the deadweight loss in this case? So deadweight loss will be equal to deadweight loss will be equal to the area of this very triangle. Okay, in the earlier video I have told you how to calculate this very stuff. Okay, so I hope you will see in the info button of this video also that very video. Okay, so deadweight loss will be simply 1/2 of the area of this triangle will be, what is the area? So we have 20 minus 10, 20 minus 10, that means this base. Okay, this very distance is 10 into what is the vertical height. Vertical height is marginal external cost. Okay, this 10, because ordinarily we were at this marginal private cost. Our this curve has shifted and it became marginal social cost only when we included marginal external cost. So this vertical distance will be 10. Okay, at any point the distance will be same here. Okay, since we have shifted our intercept by 10 units, so the distance here will be also equal to 10, which is equal to marginal external cost. Okay, so this is 10. I am just using the simple area formula, 1/2 of base into height. That means this will come out to be 1/2 of 20 minus 10 is 10. Okay, into 10. So go 10 tens are 100 but as pansa. That means our deadweight loss will be equal to 50 in this case. Okay, so the question is like this: given the per capita income distribution, okay, we are being given the income of the people like this individuals as 18,000, 21,000, 29,000, and so on up to 22,500. Okay, and the poverty line is given as 25,000. We have to find the poverty gap ratio, and answer should be in 2 decimal places. Okay, now what is meant by a poverty gap ratio? Poverty gap ratio is the ratio by which the mean income of poor people fall below the poverty line. And what does this mean? Let me write the formula for a poverty gap ratio is being found by this formula: 1 upon n denotes the number of persons. Okay, and summation from c less than z. Okay, z denotes the poverty line, p denotes the number of poor, and this c, let me write it here, Then we have Z, that's poverty line, minus C upon Z. Okay, let me write it here. What does this mean? N denotes the population, total population. Okay, total population. And our this P denotes the poor, number of poor. Okay, let me write it here, poor. And Z is our poverty line. Okay, poverty line. And C denotes the income. Okay, now what does this mean? And total population is denoted by N. Total population is here 1 2 3 1 2 3 4 5 6 7 8 9 10. So we have 10 individuals, so we can write this as 10. Okay, P denotes the number of poor. Okay, how do we define the poor here? Number of persons whose income is less than the poverty line income. Okay, we call them poor. Okay, and what is our poverty line? Poverty line is 25,000. Okay, let me write here, this is 25,000. Okay, and this denotes, C denotes the income. Okay, so the condition is C should be less than Z. Okay, we consider only the income of the poor individuals in this case. Okay, so let us see how can we write the formula here. So we have 1 divided by number of persons is 10. I can write here 10. Okay, then let me write like this. Now C should be less than Z. Okay, C, income of persons whose, which is less than 2500. How many what we call, the persons have an income less than 2500. Let us see, this 18,000 is less than 25, this is also less than 25, so these are greater than 25, we don't consider them. This is 20, this is less than 25, this is also less than 25, these are greater than 25, and this. Okay, so we have 1 2 3 4 and 5 persons. Okay, so first we write Z. What is Z? Z is our poverty line, so we have 25,000. Okay, minus this 1800, 18,000 upon 25,000. Okay, I am just using this formula here, plus, since we are taking summation from C is less than Z to P, P is here 5. We have 5 individuals whose income is less than the poverty line. Okay, so this is for individual first. Then we have again simple 21,000 minus, sorry, 25,000 minus 21,000. Okay, first we write the poverty line, then the income of the poor, and divided by the poverty line, that is 25,000, plus then we have this, then we have actually this 25,000 minus 18,000. Okay, I hope I am making myself clear. This is 25,000. Okay, then we have this number, that is 25,000 minus 23,000 upon 25,000, plus we have this 25,000. Okay, I'm just using this Z minus C upon Z, minus 22,500, 22,500 upon 25,000. Okay, now let's try to solve this out. This is 1 upon 10. Now 25,000 minus 18,000 are the so this comes out to be 7,000 upon 25,000. Okay, so this is 7,000 upon 25,000. Okay, plus 55,000 walo akusas zuto 2 so this is 4,000 upon 25,000, plus 55,000 arda b, that is 7,000 upon 25,000. Okay, I hope I make myself clear. So b 55,000 walo 3 so this is 2,000 upon 25,000. Okay, then we have 50,000 minus 5 लिखता 50,000 minus 22,500. This is 0 0 दाने 5 5. Hey, so this is 2,500. Okay, so we have 2,500, 25,000. Okay, 1,000. Okay, we can see here these three zeros will get cancelled with these zeros, these three, these three, these three. Yes, this is yes, yes. So we are left with actually 1 upon 10. Then we have 7 upon 25 plus 4 upon 25 plus 7 bata 15, okay, plus 2 bata 25 plus 25 by 25 by 200, 25 by 250, okay. When we try to solve, this will come out to be, now here we can see 1 2 3 4, the first four terms have the same denominator, okay. We can add up the numerators, okay. 7 plus 4 is 11, so kashir pat kar bhi 7 4 gay ka 7 gay arda kunutu, that comes out to be 20 upon 25 plus, now here 25 ones are 25 tens are, okay, 25 ones are 25, 25 tens are 250. So I can write like this. So start kasriyat, so we are left with this is 1 upon 10. Then we have 5 4s are 25, 5 5s are 25 plus 1 upon 10, okay. I hope I'm making myself clear, okay. So this will come out to be 1 upon 10. Now making denominator same, multiplying this by 2 to make the denominator same. So this is 8 upon 10 plus 1 upon 10, okay. So this comes out to be 1 upon 10. Then earth again, now again denominator same, we can add up the numerator. So we have 9 upon 10. This comes out to be 9 ones are 9, 10 tens are 100, okay. So we got the number is now 9 upon 100, if we write it in decimals, it can be written like this, 0.09, okay. So we can say, or if we write it in percentages, so this is 9%. That means 9% of people are actually below the poverty line, okay. So the answer should be 0.09, okay, because we are being told to write the answer in 2 decimal places, okay. We don't use the percentage here, okay. So because it is being written here, okay. Next question is, when the supply function of milk Q in ST A is being given as says Q is equal to 3p minus 300, p is the price, we have to find out the price at which no quantity of milk will be supplied in the ST. Okay, what we are being given? We are being given Q quantity is a function of price, that is 3p minus 300. We need to find out the price at which quantity demanded will be 0. So in place of Q, we will have 0. 0 should be equal to 3p minus 300. Solving this, so 3p will be equal to plus 300 when we transpose it. So p will be equal to 300 upon 3, which gives us the price of 100 when quantity supplied will be equal to 0 or no quantity is supplied. So correct option should be 100. Next question is given that when the demand function of STA for quantity and price is being given us, that means quantity is equal to 36 minus 3p, we have to find out the maximum price, okay. So price will be maximum. So price, let me write it here, p will be maximum when q is equal to 0. Simple thing. So plug in place of q, so we are being given the quantity demanded function is 36 minus 3p. So price will be maximum when quantity is equal to 0. So let us write in place of quantity 0 should be equal to 36 minus 3p. Solving for p again, we will get 3p is equal to 36, which gives us p will be equal to 36 divided by 3, which comes out to be 12. That means the maximum price will be 12. The question is to find the value of definite integral from 0 to 6 of 7x dx. The options are 62, 63, 64 or 65. So we have the definite integral from 0 to 6 7x dx, okay. We need to find the value of this very integral. On the graph, let me explain what exactly does it mean. So we have 7x function, it will go through the origin. So this is our 7x, okay. we have x on this side. We need to find the area under this straight line, okay, when x is equal to 6. So up to, let us say it is here 6. Okay, so definite integral of this function will give us the area of this very graph. Okay, so how do we take it? Simply, first we take the integral. So 7, the integral of x is x square upon 2, and we evaluate it from 0 to 6. Now we evaluate it at upper limit first, then subtract and evaluate it at lower limit. So we have 7. First we put x is equal to 6. So in place of x we have 6 square. So 6 square divided by 2. Then we subtract and evaluate it at lower limit. So we have 7 into 0 square divided by 2. This comes out to be 7 into 36 divided by 2. This term will become 0, which comes out to be 7 into 2 ones are 2, 18s are 36. So this comes out to be 7 7s are 49, 7 8s are 56, 7 ones are 7, 7 5 गए 12. So we got here 126 is the value of this integral 7x from 0 to 6. Okay, but no option is here. 126. That means the options are being given incorrect. So the correct option should be 126. Question is like this: there are two major producers in the market. Suppose the inverse demand function is given by P is equal to 160 minus 4Q, where P is the price and Q is the industry output. Okay, and marginal cost of both the firms is 0. We have to find out the Cournot reaction function of firm 1. The options are given us here, and we have to see which of these options is correct. Okay, so what we are being given here, let me write it here. We are being given the industry demand is given by 160 minus 4Q. Okay, since there are only two firms, that means this Q should be equal to Q1 plus Q2. That means total output produced by the two firms is equal to Q. Okay, so output produced by each firm is Q1, sorry, by firm 1 is Q1 and by firm 2 is Q2. Okay, and we know in the Cournot model, I have explained it in clear details about Cournot duopoly model, what are the assumptions and how do we find the reaction function. So I will just try to solve this here. Okay, this is our market demand function. Okay, to find the reaction function of firm 1, how do we find the reaction function? Let me write it here. Reaction function for firm 1 is being found by, first we need to find the total revenue for firm 1 is equal to price into quantity produced by firm 1. Okay, so what is price? Price is 160 minus 4. In place of Q we have Q1 plus Q2. Let me write it here like this, Q2. Okay, this is our inverse demand function. P is equal to this very thing. So to this we have to multiply Q1. Okay, this will give us the total revenue, and if we solve it further, this comes out to be 160 minus 4Q1 minus 4Q2, and to this we multiply Q1, which comes out to be 160 Q1. This Q1 is multiplied to each of these terms, then we have 4 Q1 square minus 4 Q1 Q2. That means this Q1 is multiplied to each of these terms. This is our total revenue for firm 1. And what is the marginal revenue? Marginal revenue is simply the derivative of total revenue function with respect to Q1. That means Q1. So derivative of Q1 is 1. So we are left with 160 minus derivative of Q1 square comes out to be 2Q1. So 2 into 4 is 8 Q1. Okay, and this exponent is subtracted by 1. I explained it so many times how to find the derivative, so I will not explain it here further. Minus derivative of Q1 is 1, so we are left with 4Q2. Okay, this is our marginal revenue. What is our marginal cost? Marginal cost for firm, since marginal cost for the firm is the same, so marginal cost for firm 1 is also same, that is 0. Okay, now for profit maximization, we require that marginal revenue for firm 1 should be equal to its marginal cost. This is our marginal revenue, so let me write it here. This is our marginal revenue, 160 minus 8q1 minus 4q2 should be equal to 0 because marginal cost is 0. Now solving for q1, if we transpose this 8q1, so this will become 8q1 is equal to 160 minus 4q2. I just transpose this term here, it became positive, and these other terms are left as they are. Okay, so q1 is equal to, if we transpose this 8, it will get divided to each of these terms. This becomes 160 upon 8 minus 4 upon 8 q2. That means q1 is equal to, this is 8 ones are 8 twos are 60, this is 20 minus this is 1 upon 2 q2, and this comes out to be q1 is equal to 20 minus 0.5 q2, and this is called the reaction function. And what does this reaction function tell us? This is the reaction function for firm 1. Okay, firm 1, we also call it best response function. Okay, best reply function or best response function. This simply says, this very function tells us optimal what you call optimal quantity firm 1 should produce given firm 2 is producing q2. Okay, so if this q2 changes, the optimal quantity chosen by firm 1 will also change, or we say it in other words that best response for firm 1 in terms of the output level decided by firm 2. Okay, if firm 2 changes this q2, firm 1 will change this q1 accordingly. Okay, because q1 is a function of q2. Okay, so I can write it like this, best response for firm 1 in terms of output level decided by firm 2. Okay, so the answer to this question should come out to be, so is it here q square? So let me see it if I have done any mistake in finding the answer. So I don't think any of the option is correct, because it is q square, it should have been like q subscript 2. Also, if it is q subscript 2, then this option should be correct. The question is to find out the second order partial derivatives. The question goes like this: find the second order partial derivatives, that is k subscript xx and q subscript yy for the following function. Okay, so we are being given this very function, we need to find out the second order partial derivatives. Let us take, first we need to find out the first order partial derivatives. Let us take with respect to x, that means q subscript x means differentiating this function partially with respect to x. Okay, since x is here, its exponent is 0.4, it will become coefficient. So we have 3 into 0.4 x to the power, and by power function rule 0.4 is subtracted by 1. Y will remain same as it is because we are taking partial derivative with respect to x. Solving this will give us 3 into 0.4, it will come out to be 0.12 x to the power. 0.4 minus 1 comes out to be minus 0.6. We have y to the power 0.5. This is our first partial derivative with respect to x. Now taking second partial derivative, that means q x x, second order partial derivative means to differentiate the first order partial derivative again with respect to x. Okay, this is our first order partial derivative with respect to x, again differentiating it with respect to x. So here we have x, the exponent will become coefficient, so we have 0.12 times minus 0.6, the exponent here. Okay, we have x then minus 0.6 and exponent is subtracted by 1 by power function rule. Then we have y to the power 0.5. It will remain same because we are taking derivatives with respect to x. So 0.12 times 0.6, it will come out to be 0.72 x to the power. Now 0.6 is minus 0.6 minus 1, it will come out to be minus 1.6 y to the power 0.5. So this is our qxx, that means second order partial derivative with respect to x. Okay, symmetrically taking partial derivative with respect to y first, so q subscript y means this time taking partial derivative of this function with respect to y. Okay, so we are interested with y variable here. The exponent of this will become coefficient, so we have 3 into 0.5. X will remain same as it is because we are taking the partial derivative with respect to y. So exponent is subtracted by 1 by power function rule, so we have 0.5 minus 1, which comes out to be 3 into 0.5, it comes out to be 1.5 x to the power 0.4 times y to the power 0.5 minus 1 comes out to be minus 0.5. This is our first order partial derivative. Okay, now we need to find out the second order partial derivative. So second order partial derivative with respect to y. This is our first order partial derivative. Second order partial derivative means differentiating the first order partial derivative again with respect to y. Okay, so this is our variable here to which we have to differentiate. So the exponent of this will become coefficient. So we have 1.5, taking this coefficient here, that is minus, multiplying it rather 0.5. X will remain same because we are taking partial derivatives with respect to y, and y minus 0.5, and exponent of this is subtracted by 1. 1.5 times 0.5, it will come out to be minus 0.75 x to the power 0.4 y to the power minus 0.5 minus 1, it comes out to be minus 1.5. This is our second order partial derivative of this function. The question is to find out the total cost. The question goes like this: a firm has fixed cost of $700 for plant and equipment and variable cost of $60 for each unit produced. What is the total cost of producing 10 units of output? Options are being given. We need to find out the correct option. So basically what we are being given, fixed cost is $700, variable cost is equal to 60 per unit, and number of units produced is equal to 10. We need to find out the total cost. Okay, now total cost is simply equal to the fixed cost plus variable cost. So what is variable cost? Variable cost is that very cost which does depend upon the level of output produced, and fixed cost is that very cost which does not depend upon the level of output produced. Okay, so it remains fixed as it is, whether output is 0 or any positive number. So variable cost will be equal to 60 times q, that means 60 times output produced. So I can write fixed cost is being given us as 700, plus in place of variable cost I can write 60 q. Now it is 700 here plus 60, and output produced is 10. I can write it here 10, which becomes 700 plus 600, which comes out to be 1300. That means total cost will be equal to 1300. The question is, which cost function belongs to natural monopoly The options are four. We need to find out which of these cost function depict the natural monopoly. Okay, in a natural monopoly, and let me write it here. For a natural monopoly, natural monopoly, average cost curve, average cost curve keeps on falling with every unit produced. Okay, due to the increase in the economies of scale. Okay, that results from the firm's high level of efficiency. We know that very thing. So in natural monopoly, if we have the graph like this, we have output on this side and average cost on this side. We are being told in natural monopoly, average cost curve keeps on falling with every unit produced. So our cost curve should go like this. It should be falling as output is produced. Average cost should be decreasing. Okay, so in all these four options, first we need to find out the average cost. So in the first case, average cost, as we know, is simply equal to total cost upon output. So total cost is here 7q. To this we divide the output. So here it comes out to be 7. Now if we draw the graph of this, we got 7. We have, output. Let us denote it by q here, and average cost on this side. So average cost is horizontal, so it is not falling, so that cannot be the cost function of the natural monopolist. Natural, in case of natural monopoly, let's take second. So average cost is simply total cost upon output. So we have 7q plus 8q square divided by power has a go. So let me do one thing here. If I can take this out. Okay, so it is winter here. To this we divide by output. So this comes out to be 7q upon q is 7 plus 8 q. When we subtract it with 1, so it will become 8q. Okay, so in the second scenario, we have output on this side, average cost on this side. If we draw the graph of this, it will look like this. 8 is intercept and slope will be positive, so average cost is increasing here. So this is not also the case of monopoly, natural monopolies, total cost function. Let's take third into consideration. So in this case, we have average cost is equal to total cost upon output. So that is 7 q raised power 1 upon 2. Let me write it here. We divided by q. So this becomes 7. If I transpose it here, it will become q times q to the power. Transposing it will get, the exponent sign will get reciprocated. So we have 7 upon, bases are same, we can add here. So we have q 1 minus 1 upon 2, it will come out to be 1 upon 2. So this will become 7 upon under root 2. Okay, sorry, 7 upon under root q here. And in this case, the graph of this will look like this. Q is on this side, average cost on this side. So average cost will be falling here because in the denominator we have under root q, 7 divided by under root q, it will decrease. Okay, so average cost in this case will decrease with each unit produced. Okay, if you draw the graph, you will see the graph of this function will look like this. So this denotes the total cost function of a monopoly. And symmetrically we can see here, this cannot be the total the total cost function of a natural monopoly. Here average cost will be equal to 7q plus 8q cube divided by q. So this is 7 plus 8 q square. So its graph will also look like uh, we have quantity on this side, average cost on this side. It will look like this, I guess, average cost. So this also cannot be the total cost function. So only this option should be then correct, because in natural monopoly, for a natural monopoly, average cost curve keeps on falling with each or every unit produced due to the continued increase in the economies of scale that results from the firm's high level of efficiency. The question is to find the consumer surplus. The question goes like this: when the demand function of Apple, which is denoted by x in a city A for price P, is being given as x is equal to 50 minus 1 upon 10p, find consumer surplus when current market price is $50. Okay, so what we are being given? We are being given the demand function for Apple is equal to, that is x is equal to 50 minus 1 upon 10p. Okay, current market price is being given us as $50. We need to find out the consumer's surplus. Okay, so there are two methods of solving this question. Since we have a linear demand function, we can use the graphical method here, and other is to use the integration. Okay, so first we will see the graphical method. So let's first draw the graph. Okay, we have the quantity of apples on the horizontal axis and price on the vertical axis. Okay, first we draw this demand function on the graph. Okay, so when x is equal to 0 in this demand function, that gives us 50 minus 1 upon 10 p is equal to 0, which gives us 1 upon 10 p is equal to 50, or which gives us price is equal to 500. Okay, so we got the price intercept. We actually need only one intercept, that is price intercept here. Okay, which is here 500. Okay, this is our downward sloping demand function. Next thing is we are being given that price is equal to 50. So current price is 50. Let us draw it here. So current price is, market price is $50. Corresponding to this price of $50, we need to find out the quantity demanded at price is equal to 50. So that can be found, that is x is equal to 50 minus 1 upon 10. We plug the price that is being given us as 50 here. Okay, 0 and 0 gets cancelled, so x comes out to be 50 minus 5, which is 45. So we got here 45. Now what is consumer surplus? Consumer surplus is simply the difference between the price that a consumer is willing to pay and the price he actually pays. The price he is actually paying is the current market price. Okay, so the difference between these two prices, rather the area of this triangle gives us the consumer surplus. The area which is above the equilibrium price or market price and below the demand curve gives us the consumer surplus. That means we need to find out the area of this very right angle triangle, and our consumer surplus will be then equal to the area of this very triangle, and we know area of a triangle is simply 1/2 of base into height. Let me write it. B is base and h denotes the height here. So we have 1/2 of, what is the base of this triangle? That's 45. Okay, it is 0 to 45. Here it will be 45 up to this. So we write here 45. And what is the height of this triangle? That is simply 500 minus 50. Okay, so that will come out to be 450. So let's write it here, 450. Solving this will give us 2 2s are 4, 2 2s are 4, carry 2 5s are 10. So we got 45 into 225. So let's do this calculation. 225 into 45. So 5 5s are 25, 5 2s are 10, 11 12, 5 2s are 10 and 11, 4 5s are 20, 4 2s are 8, 9 to 10, 4 2s are 8 tage 9. So we have 5 2 1 now tage da. So we got 10125. That means the area of this triangle came out to be 10125, and which is our consumer's surplus. Okay, this is one method of solving this question. Another method is to use the integration. Okay, so let's solve it by that very method also to make the things easier for you. So first, what we need, if we want to solve this question using the integration method, we need to find out the inverse demand function. That means first we solve this function for price, that is 1 upon 10. P will be equal to 50 minus x, or P will be equal to 500 minus 10x. Okay, also we need to find out the quantity transacted at the market price of 50. Since P is equal to 50, we can find out the x will be equal to 50. Just plug P is equal to 50 into this demand function. So we have minus 1 upon 10 into 50. It will come out to be 45, as we have seen earlier. So the consumer surplus, if we want to use the integration, consumer surplus is simply the definite integral from 0 to equilibrium quantity, which we got x, and taking the definite integral of inverse demand function with respect to x, and from this we subtract the total expenditure, which is price into x. Okay, so we have the definite integral from 0 to 45. Demand function is this 500 minus 10x. We integrated with respect to quantity. To this we subtract the total expenditure, that is P into x. This will give us the consumer surplus. Okay, this method we often use when we are being given the non-linear demand and supply functions. Okay, I was just trying to explain. We can also use this very method. It will be a lengthy one here. Now the integral of 500 will be 500x minus the integral of x will be x square upon 2, and we evaluate it from 0 to 45. To this we subtract the total expenditure. So P into x. P is 50 and our x is 45. Okay, now we evaluate these terms first at 45. That means in place of x we write 45 here first, then we subtract and evaluate it at 0. So in place of x we will write then 0. So let's evaluate it at 45 first. So we will have 500. In place of x we have 45 minus, so 2 1s are 2 5s are 10. So we are left with 5. X square means 45 square, 45 square. Okay, then we subtract and evaluate it at lower limit. Since lower limit is 0, 500 into 0 will be 0, and 10 into 0 square upon 2 will be 0 again. So we will not evaluate it at all because it will become 0. To this we subtract the total expenditure 50 into 45, which will come out to be 2250. Okay, when we solve this 500 into 45, it will come out to be 2250. 2500. I have done this calculation. 5 into 45 square, it will come out to be 10125. I hope this calculation is right. And then we have 2250. When we subtract these things, we will get 10125. Okay, so using integration, we can also calculate the consumer surplus. Now this thing denotes the area of this whole quadrilateral. Okay, so let's explain it here little bit. So let us say we have this quadrilateral. Okay, the area of this whole quadrilateral. From that we subtract this total expenditure. Okay, let us say if it is like this, and when we subtract, we get the upper triangle as the consumer surplus. So the area of this is simply the definite integral from 0 to 45 and taking the integral of demand function. To this we subtract the total expenditure, that is P into X, and we are left with the consumer surplus. Okay, so from this area we subtract this rectangle and we are left with upper right triangle, that is our consumer surplus. So when we take integral from 0 to 45, 0 to X, we are actually getting the area of this whole quadrilateral. From that we subtract the area of this rectangle and we get the area of this triangle, that is our consumer surplus. The question is to find the impact of autonomous investment on income. The question goes like this: what will be the impact of change in autonomous investment on income when consumption is equal to K times Y and investment, that is autonomous, which is equal to A? Okay, so we know from our identity that Y should be equal to the consumption expenditure plus investment expenditure. Okay, that is Y should be equal to, what is our consumption, that is K times Y, plus investment is being given as is A. So transposing this ky here, it will become y minus K times Y should be equal to A, which gives us, let's take Y common here. If we take Y common, we will be left with 1 minus K should be equal to A, or Y will be equal to A upon, if I transpose it here, it will become 1 minus K. Okay, this is our multiplier here. Now we need to find out the change in autonomous investment here. Okay, investment is being denoted by A here. To find this change, what we need to do, we simply take the derivative of our income, change in income, with respect to change in investment. Okay, so our I is equal to A, so I can write it here dA also. Okay, if we take the derivative of this function with respect to A, we will be left with 1 upon 1 minus K. Okay, so our answer will be 1 upon 1 minus K. Let us see if, yes, we have one option. The question is to find out break-even point for output. So the question goes like this: when total cost, which is TC, is equal to 2550 plus 5x and current market price is $15 per unit of output, what will be break-even point for output? The options are 255, 455, 355 or 555. Okay, so by break-even, what we mean by break-even, point of output, we mean where our economic profit is equal to 0. And what is profit? Profit is simply total revenue. Let me write it here. When total revenue minus total cost is equal to 0, and total revenue is price into output minus total cost should be equal to 0. Now let us see what we are being given. Total cost function is being given as 2550 plus 5x. Okay, price is being given us as 15. Okay, so we need to find out the quantity. So just plug these values in this equation. So P is 15 times Q should be, to this we subtract the total cost. So we have minus 2550 minus 5 x actually should be equal to 0. So in place of Q we have x. Okay, so let's write it here also x. So Q denotes the x. So 15 minus 5 comes out to be 10x minus 2550 should be equal to 0. Let's draw the graph also to make it more useful. So we have x on this side and price on this side. Rather, we have profit on, rather total revenue and total cost on this side. Okay, now our total revenue is 15 into x. Okay, our total revenue will look like this. This is our total revenue function which goes through origin, and total cost function is this, and it has positive slope. Let us say this is our total cost function. Total cost function break even point will be where total revenue is equal to total cost. At this point, at the intersection of total revenue and total cost function, we will get the break even point. So we have 10x, transposing this here, it will become 2550, or x will be equal to 2550 upon 10. That gives us break even output equal to 255. That means when our economic profit is equal to 0, the output level should be equal to 255. The question is to find out the equilibrium quantity. The question goes like this: quantity demanded, which is QD, is equal to 80 minus 2p, p is the price, and quantity supplied is equal to 10 plus 0.5p. Find the equilibrium quantity. The options are 20, 24, 22, or 26. Okay, so we are being given the quantity demanded function is 80 minus 2p. On the graph it will look like this. We have quantity on this side, price on the horizontal side. The price intercept is 80 and it has negative slope, and it will look like this. Okay, this is our demand function, and quantity supplied is being given us as 10 plus 0.5p. Okay, so it has the positive slope, and let us draw it here. So this is supply function. So at equilibrium, okay, at equilibrium, quantity demanded should be equal to quantity supplied. So quantity demanded is being given us as 80 minus 2p. It should be equal to quantity supplied, which is 10 plus 0.5 p here. Now transposing this 10 here, it will get subtracted. 80 minus 10 is equal to, we have 0.5 p. Transposing this, it will become 2 p plus we have this 0.5 p. Okay, sorry, we have only this thing here. So 80 minus 10 comes out to be 70 is equal to, this is 2.5 p, which implies p will be equal to 70 upon 2.5, which comes out to be 28. That means equilibrium price is 28, but we need to find out the equilibrium quantity. Now just plug p is equal to 28 either in demand or supply function. Let's put it into the demand function. That will give us quantity demanded will be equal to 80 minus 2, the equilibrium price is 28. This comes out to be 80 minus 56. So danishat 4 7.5, that comes out to be equilibrium quantity will be equal to 24. The correct option should be this. Okay, equilibrium occurs where demand and supply functions intersect with each other. So our equilibrium price is 28, equilibrium quantity is 24. The question is how to find equilibrium price and quantity from the following linear supply and demand equations. Supply function is P is equal to 4 upon 5Q plus 5, and demand is P is equal to minus 2 upon 5Q plus 35. Q is the quantity and P is the price. Okay, so let's first to draw the graph to make it more clear. So we have quantity on the horizontal axis and price on the vertical axis. We have the supply function. This supply function, it is vertical intercept is 5. Let us draw it here, and it has a positive slope, so it will look like this. This is our supply function. Okay, and we have the demand function. It is price intercept is 35, and it has the negative slope, so it will look like this. This is our demand function. Okay, vertical intercept is 35, and for supply function we have 5. Okay, we know that at equilibrium, demand should be equal to supply. That is demand should be equal to supply. On graph, it means equilibrium point will be that where demand and supply curves intersect with each other. Demand function is this P is equal to this equation, and supply is P is that very equation. So since P's are same here, LHS is same, we can equate RHS. So that means minus 2 upon 5 Q plus 35 should be equal to, and the supply function is 4 upon 5 Q plus 5, which gives us, let's transpose this 2 upon 5 Q here, and this 5 here, so we will get 35. Transposing this, it will get subtracted, is equal to, we have 4 upon 5 Q. If I transpose this, it will become positive, so we have 2 upon 5 Q. Okay, so 35 minus 5 comes out to be 30, should be equal to, denominator is same, we can add up the numerator. So 4Q plus 2Q is 6Q upon 5. That gives us 6Q upon 5 is equal to 30, which implies Q is equal to 30. If I transpose 6 upon 5 to RHS, it will get multiplied and reciprocated, so it will become 5 upon 6. So 6 ones are 6 5s are 30, so equilibrium quantity will be equal to 5 5s are 25. So equilibrium quantity we got 25. So here we have equilibrium quantity of 25. Now to find the equilibrium price, just plug Q is equal to 25 either in demand or supply function. Let us put it in the supply function. That gives us P is equal to 4 upon 5. The equilibrium quantity is 25, so in place of Q we have 25 plus 5. So 5 ones are 5 5s are 25, so 4 5s are 20 plus 5 is 25. That gives us equilibrium price will be also equal to 25. Okay, so we got here 25. One thing you can also see here, okay, that is not related to the question. The area which is above the equilibrium price and below the demand curve, this area, it denotes the consumer surplus, and the area which is above the supply curve and below the equilibrium equilibrium price, it denotes the producer's surplus. The question is, given LM equation is 0.25y minus 200i minus 193 is equal to 0. Y is the income, I is the rate of interest, and I's equation is being given as 0.3y plus 100i minus 252 is equal to 0. We need to find out the equilibrium interest rate. The options are 0.006, 0.066 or 0.01. Okay, so what we are being given? We are being given the I's equation is 0.25y minus 200i minus 193 is equal to 0. This is our I's equation, and this is our LM equation, and LM equation on graph shows us the positive relationship between, if we have income on this side, rate of interest on this side. This is our LM equation. It shows us the different combinations of rate of interest and level of income where demand for money is equal to supply of money. Okay, so this is upward sloping curve, and you can see if we solve it for y, it will become plus I here. If I transpose this 200i, there will be a positive relationship. Okay, our is equation is being given as 0.3y plus 100i minus 252 is equal to 0. Okay, basically in the question it was shown as negative, but it cannot be negative here because it will slope upwards. Then our ice curve does not slope upwards. Okay, so I have just uh, rectified it. It is here plus. Okay, not minus. So we have income on this side, rate of interest on this side. IS equation shows us the different combinations of rate of interest and level of income where our investment is equal to savings. Okay, so this is our IS curve, this is our LM curve. We need to find out the equilibrium interest rate. If this is our IS equation, this is our, rather let me write it here. Let us say this is equation first, this is equation second. Okay, so this is our LM equation, this is IS equation. Now equilibrium requires that IS should be equal to LM. Okay, we need to equate these two equations with each other. So we can do one thing here to solve for two variables. If it is possible to make the coefficient of one variable same, okay, without bothering about the sign, we can eliminate that variable here. Now we have here 100i. So this 100i can become 200i if we multiply this second equation by 2. Okay, so multiplying equation second by 2, so what will we get? So 2 into 0.3 comes out to be 0.6, and let me write it here. So we have 2 into 0.3 is 0.6y, plus we have 100 into 2 is 200i, minus 252 into 2, so 2 2s are 4, 2 5s are 10, 2 2s are 4, 5 is equal to 0. Let us say this is our equation third. Now we can add equation first and equation second. Okay, if we add these two equations, what will we get? So we have 0.25y plus 0.6y, it will become 0.85y. Okay, minus 200i plus 200i, it will get cancelled. Then we have minus 193 minus 504, so it will come out to be 697, which should be equal to 0. Solving for income, so we have 0.85y is equal to 697, y is equal to 697 divided by 0.85, which gives us y will be equal to 820. Okay, so basically by simultaneous equilibrium, what we mean when both goods and money market are in equilibrium. So this is our LM equation, this is our IS equation. We have rate, level of income, rate of interest. Simultaneous equilibrium requires that IS should be equal to LM. So we got equilibrium income level of 820, but we need to find out the interest rate here, equilibrium level of interest rate. What will we do? We simply plug y is equal to 820 either in IS equation or LM equation. Okay, so let's put here in this equation to get the equilibrium level of interest. So we have 0.3 in place of y, we have 820. So let me write it here, 820 plus 100i minus 252 is equal to 0. So this will become 246 plus 100i minus 252 is equal to 0. So 246 minus 252, it will come out to be this will come out to be minus 6 is equal to 0, which implies 100i is equal to transposing, it will become positive 6, which gives us I will be equal to 6 upon 100, which is equal to 0.06. That means our equilibrium level of interest will be 0.06. So I will be equal to 0.06. The correct option should be B option, 0.06. The question is to find the money market equilibrium, that is to find the LM equation. Okay, the question is find the money market equilibrium, that is to find out the LM equation given transactionary demand for money is denoted by MT, speculative demand for money is denoted by MZ, and money supply is MS, and transactionary demand for money is the positive function of income, that is MT is equal to 0.25y. Speculative demand for money is negative function of rate of interest, that is MZ is equal to 120 minus 200i. Money supply, which is exogenous here, is given as 200. We need to find out the LM equation. Now money market, rather LM curve, and let's first draw the graph, and we have income on this side, rate of interest on this side. So LM equation shows us different combinations of rate of interest and level of income where our money market is in equilibrium. And money market is in equilibrium, and let me write it here. Money market is in equilibrium when demand for money is equal to supply of money. Now demand for money has two components, that is, let me write it here. Demand for money has two components, that is the transactionary plus precautionary demand for money, that is been denoted by MT, plus speculative demand for money, that is MZ. Okay, so demand for money has two components. First is transactionary demand for money, that depends upon the level of income, which is the positive function of level of income, and speculative demand for money, which is the negative function of level of interest rate. Okay, so in place of MD I can write MT plus MZ should be equal to MS. So this reduces to, so MT is being given as 0.25y, MZ is being given as 120 minus 200i should be equal to money supply is exogenous, which is being given as 200. So solving for what, so we have 0.25y, transposing this here, so 120 minus 200, it will become negative 80. So first write 200i minus 80. This will be the condition for money market to be in equilibrium. Okay, so this is our LM equation. The question is to find goods market equilibrium. The given question is find the commodity market equilibrium from the equations given below. We have consumption function C is equal to 100 plus 0.6y. C denotes the consumption. 100 is the autonomous consumption that does not depend upon the level of income. 0.6 is marginal propensity to consume, and Y denotes the income. And investment is being given equal to 130, which is the autonomous investment that does not depend upon the level of interest rate. And I denotes the interest rate here. We need to find out the commodity market equilibrium, that is we need to find out the goods market equilibrium, so that we get the IS curve. Okay, IS curve shows us the goods market equilibrium, and it is derived simply by, that is our total income should be equal to the consumption expenditure plus investment expenditure. We use this very identity, that is Y will be equal to what is consumption, that is 100 plus 0.6y plus investment is being given as 130 minus 99i. So we have y is equal to so we have 100 plus 130, it comes out to be 230 plus 0.6y minus 99i. and we can write it in this fashion, that is y minus 0.6 y minus 230 plus 99i. So y minus 0.6 comes out to be 0.4y, then I can write plus 99i minus 230. This is our, you know, this is our commodity market equilibrium condition. Okay, so it is simply, it shows us if we have income on this side, rate of interest on this side, so this ice curve would will be, ice curve will be downward sloping, and it shows us different combinations of rate of interest and level of income where our goods market is in equilibrium. The question is to find the level of profit for a firm that has a fixed cost of $950, a variable cost of $70 per unit, and supply price of $85 when it sells 100 units. The options are given as 550, negative 550, 450, or 2450. So what we are being given here? We are being given the fixed cost is equal to $950, variable cost is equal to $70 per unit, and supply price is equal to 85, and quantity sold is equal to 100 units. Okay, now first we need to find out what is total cost. So total cost is simply equal to the variable cost plus fixed cost, and we can write total cost in this fashion. Variable cost is 70 per unit, so 70 into units, that is 70 into Q, plus fixed cost is being given us as 950. This is our cost function. Now profit is simply given as, profit is simply equal to total revenue minus total cost. Okay, so profit will be equal to, now what is total revenue? Price into output sold minus total cost. Now price is being given as, supply price is 850, unit sold is being given as 100. To this we subtract the total cost. Total cost function is 70Q plus 950. Okay, so this will become 85, so it is actually 85 only here. Okay, so this is 8500 minus we have 70 into quantity sold is 100 plus 950, which gives us 8500 minus we have 7000. Okay, this is 7000 plus 950, which will come out to be 8500 minus 7950. That gives us the profit equal to 550. Okay, 8500 minus 7950, it will come out to be 550. So the correct option should be this. I hope I made the calculation right here. The question is to find the impact of per unit change in input on price of good. So the question actually is the price of good, which is denoted by P, price of complement, which is denoted by P subscript C, price of substitute, that is PS, and price of input, which is PI, are associated with demand and supply as below. Quantity demanded is equal to K minus beta P minus C PC plus SPS. PC is the price of complement, PS is the price of substitute, and QS is A plus BP minus IPI, where PI is the price of input. We have to find out what will be the impact of per unit change in input on the price of good. The options are being given here. Okay, so first thing is, we know that at equilibrium quantity demanded should be equal to quantity supplied. So quantity demanded is being given as is K minus beta, the price of good, minus C times the price of complement, plus S times the price of substitute. It should be equal to the supply, which is being given as is A plus B, the price of good, minus I times the price of input. We need to solve this for P. Okay, so we can do one thing here. Let me first write this on LHS and this on RHS to make more sense. So we have A plus BP minus IPI is equal to K minus beta P minus CPC minus SPS. Okay, so we can do one thing here. Let us transpose this beta B, the price of good, to LHS and these terms to RHS. Okay, so I can write BP transposing this, it will become plus beta P is equal to, we have K minus CPC minus SPS. Now transposing this A here and this IPI, it will become plus I times PI. Okay, after that we can take P common here. So if I take P common, we will be left with B plus beta is equal to, so we have K minus CPC minus SPS plus A plus IPI, or I can write P is equal to, if I transpose this, it will get divided, so it will become B plus beta times this whole K minus C, the price of complement, minus S times the price of substitute, plus A plus I times the price of input. Now the question tells us to find the impact of per unit change in input price on the price of good. Okay, so by this what we mean, we want to find out the change in price of the good when input price change. That means we need to find out this very derivative, that is dp upon dpi, change in the price of good with respect to change in the input price. Okay, so we have to take the derivative of this function with respect to pi. Okay, here you can see no pi is involved, its derivative is 0, its derivative is 0, its derivative is 0, 0, because we are taking the partial derivative. Okay, so let us use the partial derivative script here. Okay, so we actually want to find out the change in the price of good with respect to change in the price of input. So only in the last term we have pi, the derivative of pi will be 1, so we will be left with only I. Okay, the derivative of all these terms will be here 0. To this we have to divide this b plus beta. Okay, so this will give us the impact of per unit change in the input prices on the price of goods, that is I upon b plus beta. Let's see. Yes, we have one option here. A consumer has the utility function uxy is equal to x minus 10 into y, x greater than 0, y greater than 0. Price of the two goods is given as price of x is equal to price of y is equal to y 1, sorry, and the consumer's money income is 5. Then utility maximizing, income exhausting, consumption bundle of this consumer is, the options are given as x is equal to 0, y is equal to 5, then we have 5, 0, 2.5, 2.5, or none of these. Okay, so we are being given the utility function u is equal to, now if we solve it here, this becomes x into y is xy, xy minus 10y. Okay, so this is our utility function. We want maximize this because we are being told to maximize utility maximize condition here. Okay, so we want to maximize this utility subject to the budget constraint. What is budget constraint? Price of x into units of x plus price of y into units of y should be equal to m. What is price of x is 1, that means 1 into x is x plus y should be equal to m. Total money income is 5. Okay, we want to maximize this subject to this budget constraint. Okay, so if we use here tangency condition requires that marginal rate of substitution between goods should be equal to the ratio of their prices. Okay, so what is MRS? MRS is marginal utility of x upon marginal utility of y should be equal to price of x upon price of y is 1 upon 1. Marginal utility of x means differentiating our utility function with respect to x. If we differentiate this with respect to x partially, the derivative of x is 1, so we are left with y only. Okay, y, and since no x is involved in the second term, its derivative is obviously 0. And marginal utility of y differentiating again with respect to y partially, so derivative of y is 1, so we are left with x minus, here derivative of y is also 1, so we are left with 10 should be equal to 1. That means y is equal to x minus 10. Okay, I hope I am making myself clear. Now we got y is equal to x minus 10. Put this value into the budget equation. Okay, so we have x plus value of y is x minus 10, so I can add x minus 10 should be equal to 5. Okay, now this is 2x is equal to transposing, this becomes 50, or x is equal to 15 divided by 2 is 7.5. so optimal value of x is 7.5. what is the optimal value of y? Again put x is equal to 7.5 in this equation, so we have in place of x we have 7.5 plus y is equal to 5, or y is equal to 5 minus 7.5. Okay, 5 minus 7.5, that means y is equal to 7.7 वालों 5, that is negative 2.5. Okay, so we got the optimal values of x is equal to 7.5. Consumer is consuming 7.5 units of good x. Okay, no problem. Consumer is consuming negative 2.5 units of good y. Is it possible for a consumer to consume negative units of any commodity? No. Okay, so if we use this very method in solving this question, so we will not get the optimal bundles here. Okay, because though our budget constraint is satisfied, but we are consuming negative quantity, and negative quantity cannot be consumed, so consumer cannot consume 7.5 units of good x and negative 2.5 units of good y. Okay, so if we solve this question like this, it is not a we cannot get the correct answer. Okay, now let us see what are the options given us here. Okay, we want to maximize, okay, maximize u. Okay, u should be equal to x y minus 10y. Okay, now let us use the elimination method here. Now x plus, also we are being given x plus y should be equal to m. Okay, now if consumer is consuming 0 units of x, 5 units of y. Okay, if consumer is consuming 0 units of x, 5 units of y, our budget constraint is satisfied. Okay, our budget constraint is satisfied, that means 0 plus 5 is equal to 5. Okay, but what will be the utility at that point? So our utility will be equal to, in place of x we have 0 into 5 minus 10 into 5, that means we have minus 50 as the utility for the consumer. Okay, now let us put this value here. Okay, when consumer is consuming 5 units of x plus 0 units of y, our budget constraint is satisfied. What is the utility that the consumer is getting? Because we are being told to find the utility maximizing consumption bundle. And what will be the total utility? Just plug the value of x is 5, y is 0, so we have 5 into 0, okay, minus 10 into what we call 10 into what is the value of y? Y is equal to 0, so this is 0, which comes out to be 0. Okay, consumer is getting 0 utility. Now when consumer is consuming, though it seems this should be the correct option, let us see. When consumer gives 2.5 units, rather consumes 2.5 units of x plus 2.5 units of y, his income constraint is satisfied. Okay, but what is the utility he is getting? Utility he is getting is equal to, now give 2.5, okay, so we have 2.5 into 2.5, okay, minus 10 into 2.5, okay. Now 2.5 comes out to be 6.25. We have minus 10 into 2.5 will come out to be rather 25. Okay, so I am not sure I have done the calculation right, but here he is also getting, let us say agar is value, it is minus 19. Okay, and this option cannot be the right one. Now you can easily find out when consumer is consuming 5 units of good x, 0 units of good y, his total utility is 0. Okay, when he is consuming 2.5 units of each good, his utility is minus 19. When he is consuming 0 units of good x, 5 units of good y, his utility is negative 50. Okay, I guess the correct option to this question should be option B. When consumer consumes 5 units of good x, 0 units of good y, budget constraint is satisfied and he is getting the maximum, what you call the utility. Okay, and this cannot be the correct one. This only satisfies the budget constraint. Okay, but we did not get the maximum utility. The maximum utility is possible when consumer is consuming all units of good x and no unit of good y. I hope I make myself clear in this video. I'm not sure whether the answer is right or not, because the question has come to me in just 5 minutes ago. So if there is any mistake in this question, you can ask me to rectify that very mistake, because I'm just a student of economics. In that capacity there can be mistakes in my videos. Thank you. Question is like this: in a closed economy with unutilized capacity, if investment rate remains unchanged and savings amount to 20% of GDP, an increase in government fiscal deficit by 100 units will cause economic activity to increase by, the options are 100 units, 120 units, 200 units, or 500 units. Okay, so we have a closed economy. So our GDP equation will be y is equal to c plus I plus g. Okay, now we are being told that our saving rate is 20% of GDP. That means this is our marginal propensity to save is equal to 0.2. Okay, and what is our marginal propensity to consume? Marginal propensity to consume is equal to 1 minus marginal propensity to save. That means this is 1 minus 0.2, which comes out to be 0.8 is our marginal propensity to consume. Okay, now I will just try to derive the multiplier, then we will see what happens when the government fiscal deficit increases. So let's write, we have y, that is total GDP is equal to consumption expenditure. Consumption expenditure is being given by a plus b y. Okay, plus we have the autonomous investment plus government expenditure. Okay, so let's write it here. So if we transpose this term here, this will become y minus b. Y is equal to a plus I plus g. Okay, if we take y common, we are left with 1 minus b is equal to a plus I plus g. Okay, or y is equal to a plus I plus g upon 1 minus b. What is this 1 minus b? This b denotes our marginal propensity to consume. Okay, so which is our b? Now the question tells us what happens when there is increase in government fiscal deficit. When will the government fiscal the deficit increase? Okay, it will increase when our government expenditure increases. That means in this case here we are being told that our change in government expenditure is equal to 100 units. Okay, so government expenditure has increased, which here means increase in government fiscal deficit. Okay, now we need to see what will happen to our GDP when the government expenditure increases by 100 units. Okay, so it simply means we need to differentiate this very equation with respect to g. So that is simply we need to take the derivative, that is del y upon del g. So taking derivative of this very function with respect to g. So derivative, it is here constant, this is also constant, only choice variable which is here, that is g. So the derivative of g is equal to 1. Okay, obviously the derivative of g will be 1, so we are left with 1 upon 1 minus b. Okay, which means which is equal to 1 upon 1 minus b is 0 0.8, 0 0.8, and it can be written like this, 1 upon 0 0.2, which was our savings rate. Okay, so this is simply 1 upon 2 upon 10, and if we reciprocate it will become 10 upon 2 this. So this is our multiplier. Okay, that means our del y upon del g is equal to change in output when government expenditure changes is equal to 10 upon 2. Okay, now what is our change in economic activity, which is del y will be equal to, if we transpose this term, it will get multiplied 10 upon 2 into del g. What is the value of change in government expenditure? It is being given as 100, which implies we have 10 upon 2 into 100. Okay, so this 2 ones are 2, 2 fives are 10, so this becomes 5 into 100, which comes out to be 500. Okay, that means change in economic activity when the government fiscal deficit increases by 100 units will be equal to 500. Okay, so the correct option should be this very thing. Okay, you can also easily calculate it simply, that is change in government expenditure when, sorry, change in y when there is change in government expenditure is simply equal to 1 upon savings. Okay, marginal propensity to save. Okay, and here you can see this is being given as 20% of GDP, so that is del y will be equal to 1 upon s into del g. Okay, that means 1 upon 0 0.2 into 100. Okay, and it will come out to be this very thing. Okay, I was just trying to solve how we get this very thing, that is why I just derived it. Okay, I hope you like these videos. Please share these videos with your economic friends. That will be only motivation for me to keep going on. Thank you.